these are some identification of ABCD type of numericals. So let us see how can you identify the ABCD here. See here C2H5O2, alcohol. Alcohol undergo oxidation to give what? Carboxylic acid. Carboxylic acid when hit with the ammonia will give what? Amide. And when amide undergo Hofmann's bromide reaction with Br2KO2, it will give to you amine with one carbon less. So what I will write? See C2H5O2 ethyl alcohol undergo oxidation to give what? CH3COH2. Then it is heated with ammonia, NH3 heat CH3CO NH2. Then what bromine and KH2 Br2KH2 give what CH3 NH2. So this is what converting your ethyl alcohol into methyl amine. Clear? Now B what you see C2H5NH2 ethyl amine. Amine but with your nitrous acid HONO will give what? Alcohol C2H5O2. Alcohol undergo oxidation will give what? Carboxylic acid. Then heated with the ammonia, amide. Br2KH bromide gives what? Amine, one carbon less. That means this is what? This is your methyl amine. Okay. So I write C2H5NH2 HONO what your C2H5OH2. Then your oxidation, okay, CH3COOH2. Then your ammonia heat, CH3CONH2. Then your Br2KOH2 is what? CH3NH2. This is your A, B, your C, your D. Clear? So ethyl amine into what? Methyl amine. Okay, already we have done this. Okay, so ethyl amine with the nitrous acid gives ethyl alcohol, oxidation, acetic acid, ammonia heat, amide, Br2KH2, Hofmann amine with one carbon less. Clear? C. Now ethyl alcohol. Ethyl alcohol undergo oxidation will give what? Carboxylic acid. Alcohol, oxidation, carboxylic acid. Now carboxylic acid into SOCl2 will give what? Acid, chloride, RCOCl. Now when acid chloride react with your sodium azide, we hit with sodium azide will give what? Acetyl azide. And this acetyl azide on hitting with water will give what? Amine. Okay. So we will get what? C2H5OH2 oxidation, CH3COOH2, SOCl2, CH3COCl, NaN3 heat, CH3CON3, then your H2O heat, CH3, and heat your CH3 and CO. Okay, then what your CH3 and H2O. So when ethyl alcohol undergo oxidation, it will give you a carboxylic acid. The carboxylic acid treating with your thionyl chloride SOCl2 will give what? Your acetyl chloride C3COCl. That when it is with the sodium azide, okay, it will give you acetyl azide. Again, when it will be heated, it will give what? Your alkyl isocyanate C3NCO. This on heating with water will give you amine. Clear? Now, benzene, chlorine FeCl2, FeCl3, phenol Kraft reaction will give what? Chlorobenzene. Then your ammonia with CO2 will give what? Aniline. Okay, simply benzene, Cl2, FeCl3, chlorobenzene. Then you have your ammonia, CO2O, you have your aniline. Clear? Benzene, CaCl3, AlCl3. Field also alkylation. Give what? Toluene. Toluene oxidation with the alkyl chemical give what? Benzoic acid. Benzoic acid, ammonia, heat. Benzamide. Benzamide, then hopfenamide. Aniline. Clear? So you get what? Benzene with what? CH2Cl3, AlCl3 will give what? Toluene. Toluene under what? Oxidation with in alkaline medium will give what? Benzoic acid. This again what? NH3 heat will give what? Benzamide. Br2 also aniline. Clear? Okay. So benzene undergo Feld-Crafts alkylation to give you a toluene. Toluene undergo oxidation with the alkyl chemical to give you the benzoic acid. Now benzoic acid when heated with the ammonia giving benzamide. Now benzamide undergo hopfenamidation to give what? Aniline. Clear? And therefore benzyl alcohol undergo oxidation to give what? Benzoic acid. Benzoic acid to take your hydrozoic acid N3H2 support to give what? Aniline with one carbon less. So what is this one? F. Benzyl alcohol oxidation will be what? Benzoic acid. Okay. Then N3H2 H2 support will give what? Aniline with one carbon less. Clear? So benzyl alcohol undergo oxidation to give benzoic acid. Now benzoic acid undergoes chemical reaction with the hydrochloric acid in place of concentrated sulfuric acid to give what? Aniline. Clear? Okay, so this is a problem basing on determination of structure. Okay, let's see an organic compound A with the molecular formula C2H4O2 CnH2O2. So carboxylic acid or ester. Now this gives effervescence with sodium bicarbonate. That means it's a carboxylic acid because the formula is CnH2O2 and it is giving effervescence with sodium bicarbonate, so it's your carboxylic acid. So what I write? CH3 C double bond O OH. Okay, C2H4O. A when hit with the ammonia gives compound B. Heated with the ammonia will give what? C3 C double bond O NH2 B. Which on hitting with the bromine and KOH gives C. Now this B, if I heat with what? Bromine and KO2, this will undergo Hofmann bromide reaction, okay, to give an amine with one carbon less. Okay, so we'll get what? CH3 NH2 C on reaction with CH3 and KOH, that you know will undergo carbon amination. This is one of the chemical property of primary amines. So primary amines, when heated with chloroform and KOH, they are giving an isocyanide or carbon amine which is having a unpleasant smell. So this primary amine on what one? CH2, Cl3 and KOH will give what? CH3 and C. And this is what? Unpleasant smell. Okay, so carboxylic acid heated with the ammonia gives amide, bromine KOH Hofmann bromide, so it's amine with one carbon less. So this on reaction with your chloroform and KOH gives your carbon amine having unpleasant smell. So from the test here is sodium bicarbonate test, where carbon dioxide gas is evaporated as effervescence, so that is given by carboxylic acid. So that's why you written what? C2H4O2 gives effervescence. So from this I confirm that the compound is what? Acetic acid. And again, because the final compound C on hitting to the chloroform and KOH is giving a compound having unpleasant smell. So this unpleasant smell compound is what? Is your carbyl amine, and carbyl amine reaction is given by your primary amine. So this is the amine. Okay. So once you confirm these two, then we can proceed this one. And we know this amines can be obtained from the amides. Clear? So this is the identification of ABCD in this problem. Clear? A is your carboxylic acetic acid, B is your acetamide, C is your methylamine, D is your methyl isocyanide. Clear? Now another one. See, an organic compound A on nitration with nitrating mixture, that means your concentrated HNO3 and concentrated H2SO4 gives a compound B. B on reduction with the SN gives compound C, which gives a compound D of molecular formula C7H5N with unpungent smell when treated with CaCl3 and KOH. So here C gives the compound D whose molecular formula is this one. This is having a bad smell, and this compound is formed when C is treated with CaCl3 and KOH. That means this is your carbyl amine reaction. So with CaCl3 and KOH means it's carbyl amine reaction, and this is what? This is your carbyl amine. This is what? Carbyl amine. Because C7H5, so it's your aromatic one. So I will add what? I will add C6H5 N C. Hala, phenyl isocyanide. Phenyl isocyanide having what? Having unpungent smell. Okay. Okay, now your unpungent smell. Now this is obtaining as what? D from C. So C is what? C is amine, primary amine. And CaCl3 KOH. Okay. Now this amine I am getting by reduction with essential from B. So B is what? Nitrogen. And this B I am getting from A when it with your nitrating mixture. That means what? Is your benzene. HNO3 and H2 suppose A, B, C and D. So benzene undergo nitration to give nitrobenzene. Nitrobenzene undergo reduction with SN-HCl to give aniline. Aniline undergo carbon elimination to give phenyl cyanide having bedsol. So this is the determination of structure of this one. Okay. So from this known formula and this test two, I'm first getting for this D. Then from the backward, I am going to get the A medical benzene. Clear? Okay. Thank you. So these are the some questionnaires basing on the class 2 and 3, that is the methods of preparation of amines. Next class onwards we discuss about the chemical properties of amines.